Welcome to this in-depth guide on connecting touchscreens to PLCs, the backbone of modern industrial automation. The touchscreen HMI serves as the intuitive operator interface, while the PLC acts as the reliable control brain executing complex logic. In this video, we'll explore the fundamental communication principles, detailed wiring methods, configuration steps, and practical troubleshooting tips. By the end, you'll have the knowledge to confidently set up a robust HMI-PLC system. Let's get started. A programmable logic controller, or PLC, continuously scans inputs from sensors and switches, runs user-defined ladder logic or structured text programs, and commands outputs to actuators, motors, and valves. The human-machine interface, or HMI, typically a touchscreen panel, provides real-time visualization, alarm management, recipe handling, and manual control. They exchange data bidirectionally over a network link. The HMI reads process variables and writes set points or commands back to the PLC. Without reliable communication, the HMI would show stale data and commands would never reach the PLC. Communication most often uses a master-slave architecture. The HMI, acting as the master or client, initiates communication by polling the PLC, the slave or server, at regular intervals, typically every 100 to 500 milliseconds for smooth updates. Popular protocols include Modbus RTU, which is serial-based using RS-232 or RS-485. It's compact and widely supported, making it ideal for simple or legacy setups. Modbus TCP runs over Ethernet, offering higher speed, better scalability, and easy integration with IT networks. Other advanced options include Profinet, Ethernet/IP, or OPCUA for deterministic performance and enhanced security. Data is organized in memory areas, coils for digital outputs, discrete inputs for digital status, input registers for analog inputs, and holding registers for set points and process variables. For example, a temperature value stored in PLC holding register 40001 can appear instantly on the HMI gauge, while pressing a start motor button on the screen writes a value to coil 00001. This polling mechanism ensures near real-time synchronization between the operator interface and the controller. Now let's look at the physical wiring. For serial communication using Modbus RTU over RS-485, one of the most common setups, use shielded twisted pair cable. Connect A+ to A+ for the data plus line and B- to B- for the data minus line. Include a GND reference wire to improve stability. Use a daisy chain topology, connecting devices in series rather than star configuration. Install 120 ohm termination resistors across the A and B lines at the two physical ends of the network. This helps prevent signal reflections. The maximum reliable distance is around 1,200 meters at lower baud rates. Always respect polarity and consult device manuals for exact pinouts. For Ethernet-based communication with Modbus TCP or similar protocols, use standard Cat5e or Cat6 cables with RJ45 connectors. Connect devices through switches for multi-device networks. Assign static IP addresses in the same subnet. For example, HMI at 192.168.1.50 and PLC at 192.168.1.10, and configure the correct port, usually 502 for Modbus TCP. Ethernet offers greater scalability, higher data throughput, and easier integration with SCADA or MES systems. Cable length per segment is typically limited to 100 meters. After completing the physical wiring, move on to configuration. First, ensure identical communication parameters on both devices, matching baud rate, parity, data bits, stop bits, and slave ID. In the HMI development software, import or manually map PLC tags to the corresponding screen objects. Download the programs to both the PLC and HMI, then go online and monitor the communication status. Common issues include no communication at all, often caused by incorrect cable continuity, reversed polarity, or mismatched parameters. intermittent data can frequently be fixed by adding termination resistors or lowering the baud rate. Displaying wrong values usually stems from incorrect register addressing or data type mismatches. Noise-related problems are best addressed through improved shielding and grounding. To recap, effective HMI-PLC communication relies on master-slave protocols like Modbus, proper RS-485 or Ethernet wiring, careful parameter configuration, and close attention to noise immunity and termination. Mastering these elements will help you build reliable, maintainable automation systems. If you found this useful, please like and subscribe. Leave your specific HMI or PLC brand questions in the comments. I'll cover them in future videos. Thanks for watching, and stay safe out there in the plant.